made a useless machine with a twist. This one Hertz itself. According to online 555 timer calculators, you can make the astable oscillator circuit flash an LED at exactly 1 Hertz using these resistor and capacitor values. Unfortunately, I didn't have those exact components, and those that I did have were only 10% tolerance. So the frequency was quite a bit off from the 1 Hertz target. But if I introduced a 5K potentiometer, I could get fairly close to 60 blinks per minute. While I acknowledge that a flashing LED can be pretty exciting, I think it would be more impressive if this circuit did more than emit electromagnetic waves. I wanted it to move matter. Connecting up the 555 timer IC to switch a DC motor on and off was pretty straightforward. However, the position of the motor shaft was completely unrelated to the state of the 555 timer. I wanted the motor position and LED illumination to correspond. Now I know that the obvious thing to do would be to use a servo or a solenoid instead. The thing is, I have a sizable collection of scrap DC motors in my junk bin that I'd like to put to use. I believe that if we also included a photo interrupter to sense the motor position, we can make a fairly simple analog circuit that will do what we need. In addition to DC motors, I also have a lot of old diodes and full bridge rectifiers in my pile of junk. I also have these counterfeit op-amps. The labeling is fake. Try connecting up power according to the pinout suggested by the label, and very bad things happen. As I recall, these behaved more like cheap clones of the LM358 dual op-amp. Let's try using them. So this circuit adds a full bridge rectifier and dual op-amp to the NE555 astable oscillator. When pin 3 of the 555 is low, the green LED illuminates only when the photointerrupter sensor is not blocked. And conversely, when pin 3 of the 555 is high, the green LED illuminates only when the photointerrupter sensor is blocked. In other words, with photosensor blocked, both LEDs are in phase. Unblocked, the green LED is inverted with respect to the 555 timer output. So what happens if we switch a DC motor on whenever the green LED illuminates? Here the photointerrupter sensor is blocked during half a rotation of the disk. The disk now rotates exactly once per cycle of the 555 astable oscillator. Disk rotation now corresponds with the 555 timer output. Achievement unlocked. Let us take a closer look at the circuit. You can immediately recognize one op-amp being used as a Schmitt trigger to convert the photointerrupter sensor's analog signal into a discrete on-off pulse. It might take you a bit longer to realize the second op-amp being used as a comparator with the full bridge rectifier together form an exclusive OR gate. How does it work? If the output of the Schmitt trigger at A and pin 3 of the NE555 at B are both high, the left and top diodes switch off, the right and bottom diodes switch on. The voltage at C will be higher than at D, and so the op-amp comparator output is low. If A and B are both low, then the left and top diodes switch on, the right and bottom diodes switch off. The voltage at C will be higher than at D. Comparator output is low. If A is low and B is high, the left and right diodes switch on, the top and bottom diodes switch off. Voltage at C will be pulled lower than at D, and the comparator output's high. If A is high and B is low, the left and right diodes switch off, and the top and bottom diodes switch on. Again, C will be lower than D, and the comparator outputs high. This is an oversimplified explanation. The LM358 is not a rail-to-rail op-amp. It cannot pull its output as high as the NE555 can. Yet, the circuit still works thanks to the LM358 being able to pull its output very close to ground. So the proof of concept breadboard circuit works. Time to put it to use doing something useless. I've now transferred most of the components from breadboard to protoboard and soldered them in. I've also attached the photo interrupter sensor to the frame holding the disc and motor. Let's give it a quick test to ensure that it's still working. Staying with the theme of using up my junk bin components, I shall make use of corrugated cardboard and discarded pieces of wood. The only part I ordered specifically for this project is this mini shaft coupler for drill bits. You must be wondering, did I do all this work just to make a silly dad joke? Well, yes, but this being a kinetic sculpture, I shall leave the interpretation up to the viewer. One might see it as a social commentary. It is in our nature to destroy ourselves. One might also meditate upon our own mortality. With each passing second, some part of ourselves gets slowly worn down. We cannot know which second the machine will ultimately come to a halt. We should spend those remaining seconds wisely.